Okay, pause the video and copy all this down. Okay, we'll start by just taking this system, putting it into a matrix, and reducing to echelon form. Okay, so I had you read theorem 2 here. So to use theorem 2, I just need echelon form. So reduced echelon form, what do I get? Choose my blue. It's a bit too small, a bit bigger. Okay. So what do I do? Row 2 minus row 1, row 3 minus C row 1. Okay. It's a strange thing, but it will kill that guy, which I want. Subtraction 0, C minus 1, 0, 1. C minus C is 0, C minus C is 0, C minus C squared. 0 here. Okay, that's echelon form. So I'll try to use theorem 2. Okay. System is consistent if and only if last column is not a pivot column. So I'll look at my matrix and I'll say, well, how can this last column be a pivot column? Well, I would need that to be a pivot. So that would require that this is 0. So there you go. C is equal to 1. We'll make that a pivot column. So that's what I'll write down now. C is equal to 1 gives me inconsistent. Inconsistent. C not equal to 1. That'll give me consistent. Okay, remember consistent means unique solution or an infinity of solutions. So I could do a little diagram here. You can have, I could have a bit more space here. C is equal to 1. No solution. C is not equal to 1. Consistent. Now, under consistent, I want to have, unique. Is it unique or is it infinite solutions? So C is not equal to 1. So under the C is not equal to 1. Let's start thinking there. So C is not 1. So what does that mean? That means I have a pivot here. Now, when am I going to have infinite solutions? Well, I look at theorem 2 again, and it says if there's a free variable, then you have an infinity of solutions. Okay, so now we're assuming C is not 1. So this is a pivot. That's a non-zero number. Now, how can I have a free variable for this column? Well, I would need C minus C squared to be 0. So let's write that down. So free variable and consistent if C is not equal to 1 and C minus C squared is equal to 0. So if I can factor that, right, C 1 minus C is equal to 0. Now, if I take these two things together, C is not equal to 1, but this product here is 0. How can that be? Well, C has to be 0. And then finally, so I can put that in my little diagram over here. C is equal to 0. So I don't have to think about unique now. Unique is the only possibility left for the remaining C values. Okay, so if C is 1, then I have no solution. If C is 0, then I have an infinity of solutions. So unique must be the other scenarios. C is not equal to 1. C is not equal to 0. Because that covers all possible C values. Okay, if C is 1, no solution. If C is 0, I have an infinity of solutions. Any other case, unique solution. And you can double check this by looking at that matrix there.